Okay, good morning, everybody. Hope you guys are doing well today. I am going to pick up where I left off in yesterday's video. We are in Chapter 0, Section 6, and I left off just at the end of writing um, repeating decimals as fractions. So we're going to pick up right here and discuss what a perfect square is and how to simplify radical numbers. So the first thing that you need to know is what a perfect square number is. A perfect square number is a number that is generated by multiplying a number times itself. So for instance, when you take 1 times 1, you get 1. When you do 2 times 2, you get 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on. So you can see the perfect square numbers there and then also there. So all the way up to 15 times 15, which is 225. So it would be helpful if you had those numbers committed to memory at some point because it makes it much easier to do what we're about to do, which is simplify radical numbers. So there is this box here you can always refer back to if you need it. Um, so these are all square roots, and you can see it's the opposite operation. So if you want to undo squaring something, you square root. So when you take the square root of 1, you get 1. When you take the square root of 4, you get 2. Take the square root of 9, you get 3. The square root of 16 is 4, and the square root of 25 is 5. And so on, you can see here. Here's the rest of the perfect squares that I'm highlighting. Excuse me, I had a hiccup there. So there's your perfect squares and then your square roots of the perfect squares. So what do we need this for? Well, here is something that we can use to reduce square roots. And so looking at part A, you can see that that says to find the square root of 121. So if we go up to 121, we can go up here and you can see the square root of 121. Let me erase all this so it'll be easier to see. But the square root of 121 is indeed 11. So this one right here is 11. Now the next one is a little bit tricky because uh, this one's not immediately obvious what it might be. Um, So we can try a few things. And the first thing that I would try doing is let's just try multiplying a couple numbers together. So for instance, if I did, let's see here, I don't know, let's do 20 times 20. When we do 20 times 20, we get 400. So that's not quite big enough because our number is 529. So let's jump up, let's do 23 times 23 and see what happens there. 23 times 23 ends up being, oh, look at that, 529. So by going through and just trying, guessing numbers, because it's bigger than any of the numbers we had in our charts before, we found that 529 is a perfect square. So that means the square root of 529 is 23. Moving on to the next one, you can see this is a fraction. So the way you do this is you take the square root of 64 individually, and then you take the square root of 16 individually. The square root of 64 is 8. The square root of 16 is 4. Now from there, 8 divided by 4 is 2. So there's our final answer. D is done very similarly. We just leave the negative there and we're going to do the square root of 25 and then we're going to do the square root of 144. Looking at the square root of 25, that is equal to 5. And the square root of 144 is twelfths. So we end up with 5 twelfths for part D. Now this one wants us to estimate the square roots. Now this is a little trickier than the last one. What you have to determine is you need to determine what two numbers this 34, what two perfect squares this 34 falls in between. And the two numbers that we're going to look for here, one bigger and one smaller. So if I go up here, where our number, remember our number is 34, So we're going to go up here and find the two numbers that 34 is in between. And if you notice, there's a 36 right there, which is a little bit bigger, and then there's a 25. So 34 falls in between 25 and 36. And you can see the square root of 36 is 6, and the square root of 25 is 5. So what that means is if the square root of 25 is 5 and the square root of 36 is 6, our number, square root of 36 is 6, and the square root of 25 is 5. Our number 34 falls right in the middle of that. And 34 is a little bit closer to 36, so we're going to estimate this. It has to fall between 5 and 6. So I'm going to say it's 5.9. And that's how you estimate that, because it falls somewhere between 5 and 6. Now, the square root of 97 in our next one, we've got to figure out what two perfect squares 97 falls in between. So if we go back up here, you can see we have the square root of 97. 97 is smaller than 100, but it's bigger than 81. So there's our two. We have square root of 81 and square root of 100. So we're going to write those two down. We have the square root of 100 up here and the square root of 81 there. Now we know the square root of 100 is 10, and we know the square root of 81 is 9. 97 is a little closer to 100 than it is 81. And you see it has to fall in between 9 and 10. So I'm going to go with, let's say 9 point, we'll go with 9.9, because 9.9 falls in between 9 and 10. So the square root of 97 is 9.9. So that's how you estimate a square root. The last thing to discuss is what is the difference between a rational and an irrational number. So irrational numbers can be fractions. They can be repeating decimals, and they can be terminating decimals. Sorry, I ran out of room there. So fractions, repeating decimals, terminating decimals, and then of course they can be whole numbers. They can be integers, whole numbers, and natural numbers. They can be integers, whole numbers, and natural numbers. Irrational numbers are going to be a much smaller subgroup. They are only going to be uh, decimals that do not repeat and do not terminate. So we can say non-terminating decimals, and also non-repeating. Whoop, didn't mean to do that. So non-repeating, non-terminating decimals, or square roots of non-perfect square numbers. And there you go. So there's a good explanation between what a rational and an irrational numbers are. All right, guys, take care. As always, if you have any questions, send me an email, mccalls@shaler.us.